Alright, today we're going to talk about rotations and dilations. Yesterday was about translations and reflections. Rotations are the hardest ones, so make sure you're paying attention. So a rotation is a transformation that turns every point of a preimage through a specified angle and direction around a fixed point called the center. So remember that a rotation is a turn. There are two directions that you guys need to know. You need to know clockwise. So think of looking at the clock. So a clock goes around this direction. Counterclockwise is the opposite way. So if you have to look at a clock and know the difference between clockwise and counterclockwise, look at the clock to help you. The first one says, draw the rotation image of each figure. I have already drawn for you, like yesterday, A, B, and C's vertex with your triangle. So here's the things you have to pay attention to. It says draw the image of triangle ABC under a rotation of 90 degrees. That's the first thing. Clockwise is the second. 90 degrees clockwise. The first thing that I need you all to do is to put a 0 degree to the right. And put a note. This is where 0 degrees always goes. Every time you do a rotation, the 0 degrees goes to the right of the x-axis. We are now going to draw where 90 degrees. So the first thing you all need to realize, when you have a coordinate plane and 0 degrees is here, this is where 90 degrees is. This is where 180 degrees would be. 90 more degrees would be 270 degrees. So if you were drawing clockwise, it would be 90, 180, 270, and then when you come full circle, a circle has 360 degrees, but we won't be doing any 360 degrees. I just need you to know 90, 180, sometimes 270. So because this says clockwise, I am going to draw an arrow to go down to this spot right here. Now, if you need that re-explained, the substitute can go backwards and play it again. But here's the things. 0 always goes to the right. You're going to draw an arrow where 90 degrees clockwise is. This is the hard part. Okay? So put a little asterisk here. It says, turn your paper so the specified angle is where 0 degrees should be. This statement, you have to know what it means. Turn your paper so the specified angle is where 0 degrees should be. Now I'm going to have to turn my paper here on the screen. What I want you to realize is the specified angle is 90 because we just did that. You want to turn your paper so that 90 is where 0 should always be. And I told you 0 should always be to the right. So let me see if I can turn my paper the way this looks. I'm going to have to pause. Okay, so I figured out how to make the screen turn the paper. So I'm going to hit pause again, and when it comes back on, the paper is going to be turned. So the specified angle 90 is where the 0 should be. So see if you have your paper turned correctly. Alright, so this is where the 90 should be. The 90 should be to your right because this is where we always want 0 to be to our right. So the next thing you need to do is you need to know where point A, B, and C lie. And this is now your new coordinate plane. So you're looking at your paper now, and this is like the new origin. That's 0, 0 right here. I'm going to erase this in a minute, but this is 0, 0 right here, okay? So I need to pull this screen down so we can see what A is. A is at 2, 1. I'm going to write them here so I can see them. A is at 2, 1. B, it says, is at 3, 4. And C is at 5, 1. So after you turn your paper, you just graph these points. So A prime will be at 2, right, 1, 2, up 1. This is now where A prime is because you're looking at your paper as this is the normal coordinate plane. Next, you would graph B. B is at 3, 1, 2, 3, 1, 2, 3, 4. B prime. And C would be at 5, 1. 1, 2, 3, 4, 5, up 1. C prime. I'm going to connect these. And you know I like to shade in my image. And I'll let you look at that for a second before I turn my paper around. So all I did was turn my paper so the specified angle is where 0 should be. And I used the original ordered pairs. I graphed them as I was looking at the coordinate plane. Now I need to turn my paper back around to the original spot. Whoops, that didn't work. Hold on. There we go. And now you see what it looks like. Alright? Let's go down to the next one. The next one says triangle ABC with these vertices. The vertices are already there. So we want to look at the following. Counterclockwise, 90 degrees around the origin. So we are going 90 degrees counterclockwise. So, first thing, we put 0 where 0 always goes. 0 always goes to the right. I'm now going to draw an arrow to 90 degrees counterclockwise. Now, counterclockwise goes this way, and 90 degrees would be up here. All right? So what I want you to do now is turn your paper so the 90 degrees is where 0 should be. Just like we did on the last one. Turn your paper so the 90 degrees is where 0 should be. Alright, so your 90 degrees should be turned, whoops, sorry. So it's over here on the right. Oh, I just did it again. The 90 degrees should be right here because that's where 0 is. So remember, this is now a new coordinate plane, and I know this is getting fuzzy because I keep taking pictures of things. So on your notes, it says A should be at negative 1, 4. B should be at negative 3, 5. And C should be at negative 5, 2. So you're going to look at your paper from this perspective, and we're going to graph A at negative 1, 4. So we're going left 1, up 4. So A prime would be here. B is at negative 3, 1, 2, 3, up 5. B should be here. And C is at negative 5, 2. 1, 2, 3, 4, 5, 1, 2. There's your C prime. And then you use your ruler, connect your points, and you know I like to shade mine in. And that's what it should look like for this one. And I will turn my paper so you can see it from the front perspective. Okay, so from the front perspective, this is what it should look like. Okay? Let's go to number 3. So go to the back. Number 3. We're going to skip the chart up there. I'll explain that to you when I come back. So number 3 says, triangle PQR has these vertices. This one says a rotation of 180 degrees clockwise. So we need to go 180 degrees clockwise. So it's the same process. Put the 0 degrees where it always should be. There's 0 degrees. Clockwise 180. So we're going to go down to here. That's 90. We're going to go all the way up here to 180 degrees. So you're going to turn your paper so the specified angle, which is 180, is where the 0 should be. So I have to pause and redo it. So give me a second here. So when you turn your paper, that 180 should be the right. So the points that we're going to graph, we need to put P at negative 2, negative 3. We need to put Q at 2, negative 1. And we need to put R at 3, 2. So remember, you're looking at this now as your new coordinate plane. 0, 0. We're going to go left 2, down 3. 1, 2, 1, 2, 3. Here is where P prime is going to be. We're then going to put Q at 2, negative 1, right 2, down 1. That is Q prime. And then we're going to put R at 3, 2. 1, 2, 3, 1, 2. There's your R prime. Connect them, connect them, connect them, and shade them in. So that gives you 3 different examples. And since I'm not here, we're going to stop on the rotation homework. If you want to try the bottom one, you can. But I'd like you to switch to your dilations notes. So let's switch to dilations. And this is the last one. Dilation is a transformation in which it may be a different size. Now, those of you that go and get your eyes checked, if you've ever had them dilated, that center part gets bigger and smaller. A dilation has a center point and a scale factor. That's what you're concerned with. It preserves the angle measure and not the distance. That's why it's a different size. It says dilations produce similar transformations. It does not have isometry. All the other ones have isometry because they have the same shape, same size. So this part here is important. So if you've not been paying attention, pay attention to here. A scale factor, you take the image length over the pre-image, and it's known as the letter R. Now I like to remember this, that I comes before P in the alphabet. So I goes in the numerator and P goes in the denominator. It says here, if the scale factor is greater than 1, we call this an enlargement. Now remember, if you see a scale factor R, which is 2, 2 is bigger than 1, so that's an enlargement. And some people think that 4/3, just because that's a fraction, it's not larger than 1, but it is. So that is going to be an enlargement. It says if the scale factor is less than 1, but greater than 0, it's a reduction, so it gets smaller. So that would be if you had R equals 1/3 or R equals 3/4. here says that the scale factor is equal to the 1. We call this a congruence transformation. And the next step here is your notation. Oh, sorry. It's not letting me move this. There we go. So we had a notation chart like this yesterday. If you have XY, you notice the image has RX, RY. This just means to multiply the scale factor. And I'll show you how to do that here in a minute. Multiply the scale factor. So you're going to take your ordered pair and you're going to multiply it. Okay? So here's our first example down below. I gave you the trapezoid. I gave you the ordered pairs. I graphed it for you. Find the image after a dilation centered at the origin with a scale factor of 1/4. So scale factor is the letter R. We're going to write 1/4. The first thing you want to ask yourself, is this going to get bigger or smaller? Hopefully you said smaller because it's less than 1, so this is going to be a reduction. You take your original ordered pair E. It is -8/4. So to find E prime, you're going to take the scale factor 1/4 times -8, and then you're going to take 1/4 and multiply it by 4. When you take 1/4 of -8, you get a -2. When you take 1/4 times 4, you get 1. So I now know that E prime is at -2, +1. So what you want to do now, and I'm going to do it for you, since this video is getting long here, you would do the same thing to find F prime, G prime, and H prime. Now I'm going to give you the answers. You do not need to multiply them, but you would need to realize you would have to take 1/4 times all those ordered pairs. So F prime is -1, 2. G prime is 1, 2. H prime is 2, 1. Once you would get all your new points, you would go graph them. So -1, 2 is here, F prime. G prime is 1, 2, it's here. And H prime is 2, 1 right here. You would then connect your points. I like to shade mine in. And this is an example of a dilation that is a reduction, so it got smaller. Okay? If you have any questions, hopefully the sub could help you understand how I got my primes. We're going to do 2 more on here, and then you should have some time to work on your homework. So go to the back. The last thing I need you to know is to make sure you can figure out how to tell what type of dilations these are. So, the first one says, determine whether the dilation is an enlargement, reduction, or congruence transformation. So you need to remember from the front of your notes, scale factor, and it said to always take the image, I, over the pre-image, P. Remember I said, I remember the alphabet, I comes before P. So there's 2 ways to do this, and I'm going to show you one way on number 2 and a different way on number 3. So on number 2, one of the ways you can do this, remember the image has the prime. So I'm going to pick this, H prime, that's my image, and I'm going to pick H as my pre-image. What I'm going to do is write down the ordered pairs. So H prime's image is the ordered pair 0, 10. I'm going to put that over H is image, pre-image, I apologize, which is 0, 2. So let me go back. This is the image over the pre-image. And then you look at your numbers that you have. You can't use these zeros, but you can use the 10 over the 2. 10 over 2 simplifies to 5 over 1, which is bigger than 1. So you ask yourself, did the image become an enlargement? And you should notice that, yes, the image is bigger than the pre-image. So this is an enlargement because that's what the question asks. And the scale factor is 5 or 5 over 1. So one way to find that is to use the ordered pairs. The second way is to count the units. So I'm going to pick P to Q and P to Q. So remember, first off, you want to have the image, and if I count these boxes, that's 1, 2, 3, 4, 5. So PQ distance is 5. And then I count the boxes over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. PQ's distance is 15. 5 over 15 simplifies to 1/3, which means this image got smaller, which it did, and that is a reduction. And that's it for the notes today, because that's 20-some minutes long. So hopefully you have some time to finish your homework and get it started. I believe you have 8 questions just like yesterday, and I'll see you tomorrow.